So when I make up problems, a lot of times I try to do stuff that comes out of my own experiences. The last 2 years I've been renovating this apartment, which has given me a lot of opportunities to do a bunch of technical stuff, which I really love. I enjoy doing physical stuff. So the first question is just a basic addition question, 1/2 plus 3 7/8. I think that was the question. You guys correct me if I don't remember it right. All right, and how would you attack that problem?
I started by changing the 3 7/8 into an improper fraction.
Okay, so we can use that little checkup technique.
Yeah.
We multiply and then we add, boom, like that.
Mhm.
So that's 3 times 8 plus 7. So that makes 31. So 1/2 plus 31/8. All right, and then what?
Then you multiply the 2 and, well, by 4. So, yeah.
So we're going to scale this fraction up by 4. So we're going to be looking at 4/8 plus 31/8. And that's 35/8.
Mm-hmm.
Anybody do it differently? Generally, there's more than one way to do stuff in math. So, I mean, the way I would think about this, especially if I was trying to do this in my head on the site, is I know that I need 1/2 to be an 1/8, so that's scaling it up. That's the same step. But I'll just bring an 1/8 over to finish this off. I mean, I got 3 7/8. One more 1/8 would finish this off. So that's 4 and 3/8, right? Where did the 3/8 come from? Well, I took one of the 8s over here to finish this off. So I added my 8 here, and I took an 8th off here, and that's where I got 4 and 3/8. And that's the, finished mixed number answer. So just a different way of thinking about it. Again, there's nothing inherently better or worse about either of these representations. This is the mixed. This is the improper. Improper is better for multiplying and dividing. Mixed is better for knowing where it is on the number line. That's kind of the major benefit of both of those formats. Okay, let's talk about the next one. So you got a plumber, needs a bunch of the same size pipe, which I think is what, 4 3/4. So you got 4 3/4, but you need 23 of these things.
Yes.
And you're wanting about an 8-foot stick, because when you buy copper, you buy these big sticks of copper, and then you cut it up. So is that enough?
I got no.
What's the math behind it?
Well, I hope I did it right. But so I did, first I made it into an improper fraction and got 19/4.
Okay.
Then I just multiplied the 23.
And when we multiply, we just go straight across, right?
Yeah.
So 19 times 23 is a pretty big number.
Yeah, 437
Sounds good.
over 4.
Okay.
And then this is where so I just changed it into a decimal and saw that it was 109 point blah blah blah, and then I realized like 8 feet is only 96 inches. So yeah.
So again, there's that conversion aspect in here, because we're talking about feet, we're talking about inches. So at some point we've got to get them into the same unit so that we can compare and think about whether we have enough. So yeah, no, this is not enough. And the next question we could ask is, how much are we going to get out of an 8-foot stick? But we'll leave that for an extra extension. So again, there's there's the mechanics of what you have to be able to do. The first thing from day one was just, we need to be able to multiply, divide, add, subtract fractions. There were some other types of problems that were basically just addition and subtraction, and just reading and thinking about the context. Now, one of the things about this course is that because it's a course for all the technical different options that a person could be doing at the college, you know, there's some applications which are going to fit with what you imagine yourself doing, and then there's some applications that maybe don't fit as well. But again, I kind of think about it as a jack of all trades. You know, if you're interested in tech career, you're going to be doing physical stuff that involves, maybe you're going to be redoing something in your house, or maybe you're, you know, going to be helping somebody with their car. So there's all kinds of other opportunities for you to be working and thinking mathematically in those contexts. So don't get too hung up on this applies to me or this doesn't apply to me. Okay, so let's take a look at the sample problems here from section 4. And again, I want this to be as interactive as possible. So anytime you have a question, don't worry about interrupting me, just get it out there. Okay, so this is the actual, you know, first homework assignment out of a chapter that you're going to be tested on. So let's just take a look at what kind of concepts we're dealing with here. Okay, so you see the word ratio in here. Diameter of pulley A, diameter of pulley B, and it's asking about a ratio. So if you haven't thought about ratios in a long time, you might be saying to yourself, what the hell is going on here? But they kind of give you a big hint here, which is that building a ratio is just a comparison of two things. And these appear all over the place in the tech trades, because ratios are a good way of putting two related pieces of information together. So in this case, they've literally labeled this for you, A and B. So all you have to do is put the numbers in the right spot. You can get it wrong by putting the numbers in the wrong spot, but you really don't have to do anything else but get the numbers into the spot that they belong. So this is 15 to 9. That's it. Now, eventually, when we turn that into a fraction, we could simplify this. They're not asking us to, but let's just talk about what would happen in that case. If we make a fraction out of it and we want to simplify that ratio, what's that look like? You know what I mean by simplify? We talked a little bit about it on Monday.
You divide that, right?
Yeah, we can divide both of them by the same thing. That's a little different than just doing 15 divided by 9. That gives us a decimal version of that ratio.
The remainder.
But here I just want to know, what can I divide both of these by evenly?
3.
Yeah, so if I divide both of them by 3,
Oh, yeah.
then this would be 5 over 3. So this ratio is a little simpler than this ratio. Okay? So let me give you another example of where ratios appear. In my renovation project, when I was doing my own plumbing, when you run PVC pipe for a drain, you got to make sure that it goes down, because if it goes sideways, you're going to have standing water in your drain. So there's code that tells you what the angle needs to be, and they give it to you as a ratio, which is that the drop of elevation needs to be 1/4 of an inch for every 1 foot of run. So that is a ratio that's communicating something important about the specifications for doing drain in your house. All right, let's see what the next kind of question looks like. So I can click on this drop down and I can choose another question, just kind of zoom forward here. Okay, now just a brief side note about help, right? You've got a question help button over here, and you've got, these two are probably the best tools for you. when you do help me solve this, it'll basically walk you through step by step. Now, remember what I said earlier about solving math problems. There's always more than one way to solve problems. So they can only give you one way to do it. That's the downside of a computerized program. The plus side is they have a built-in way to do it. You're not on your own. If this was a textbook, you'd have to kind of sort through the book and figure out, well, where do I get a problem that's like this and tell me how to do it. They've got it linked right here so you can get the example that you need. They've also got links to a textbook and a video. Those might be helpful. Here's my advice about solving these types of problems. And what I would say is that a proportion is basically just a comparison of ratios. So we said a ratio is a comparison of two numbers, and a proportion is a comparison of ratios. So in other words, something like, does A over B equal C over D, right? And I could state that as a question, or I could state it as, you know, a requirement. So going to this problem, how do I figure out what this number would need to be in order for this to be true? Well, the easiest, well, anybody have an idea? Remember how to do that?
You multiply.
Cross multiply.
Yeah, you cross multiply. Mm-hmm.
Yeah. I just remember multiply diagonally and then divide by the other number. So this pair of numbers can be multiplied diagonally, and then divide by the other number. Now, some people will write out a whole equation and get X involved and solve it algebraically. You're welcome to do that, but you really don't need any algebra here. You can just do the 34.83 times 1.1 divided by 8.1. Okay, you guys got an answer?
Seven, 3.
That sounds right. Now, just pay attention to the little instructions underneath there, because sometimes they'll trip you up by telling you to round it or something. Here, they just said whole number or decimal, so there's nothing really for us to do. Check the answer, bada boom, bada bing, we're on to the next thing, okay? All right, so let's check out something more from the end of this set to see if it gets harder. All right, that looks pretty crazy. So this is an auto example, engine compression, not something I know a lot about. The compression ratio is 9.5 to 1. The expanded volume is 19. What's the compressed volume? Right? So again, I don't know whether you're in the automotive trade or not, but it is really important here that you can kind of associate expanded versus compressed. One of those is bigger and one of those is smaller.
So
So which one's bigger and which one's smaller?
expanded is bigger and compressed is smaller.
Right. So I would set up my proportion here. I got a 9.5 to 1 ratio. It makes sense that the bigger number would be on top, right? And the smaller number would be on the bottom. And so the expanded is the bigger number, and they gave it to me as 19. I'm going to put 19 here. Now I'm back to multiply diagonally, divide by the other number.
Two.
Okay, let's try it. Boom. Okay, so that's a good example of where the proportion is not given to you. You've got to do the work to set it up. So you see how they kind of worked you through this problem set. They introduced ratios in problem 1. Then in the middle of the problem set, you're solving ratios or proportions that are already built for you. And by the end of the problem set, you're having to build your own proportions. Okay. Let's take a look at the next problem set. So again, ideally, you know, you would work through those and do 100, get 100%, be like, bam, I got this, I'm feeling good. Okay. A lot more words here. I wonder if there's a way for me to zoom in. Yeah, there we go. I'm actually going to copy this, bring it over to Excel, because it doesn't. I feel like we're missing a word. I'm just going to go back and check the problem here with the displacement of. There we go. All right. So again, if you're not in the automotive area, you don't have any relationship with engines, this is just kind of a harder problem. But think about it logically. A bigger engine is going to give you more horsepower or less horsepower? What do you think? Bigger engine, more horsepower or less horsepower?
It's gonna give you more horsepower.
More horsepower. Okay. Let me give you a shot to do this yourself. I want you to set up a proportion. You've got three numbers, 230, 360, and 220. See if you can set up a proportion and generate the answer to this question, which is how much horsepower does a 230 cubic inch engine produce? Okay. So the tool that we just learned will work great here. Set up a proportion and see if solving it can give you a reasonable answer.
I honestly don't even know where to begin, but I'd assume that you
No,
would.
no, hold on, Ricky. Give everybody a chance.
Okay.
You already set it up?
Yeah, I got an answer, but I don't know. It's anywhere near the ballpark range.
Okay. Well, without saying it out loud, here's how I would think about if your answer makes sense. You know that the 360 engine is bigger, right? And it's producing 220 horsepower. So if my 230 cubic inch engine is producing less horsepower than that, I would feel good. If it's producing more than 220, I'm not feeling good about it because I got a smaller engine, should be producing less horsepower. That's how proportionalities work. Okay, does everybody get a chance to set it up and try it out? Somebody other than Ricky want to give me the setup?
So I did 230 over X equals 360 over 220.
Okay. Now, one thing that I would say about your proportions
Mhm.
is that in general, you want them to be consistent. So what I like about this setup is that we can look at this and say to ourselves, yes, this is consistent. What do I mean by that? The top numbers are the cubic inches. It's the size of the engine.
Mhm.
The bottom numbers are the horsepowers, and that's the, the power that the engine is producing. So we were consistent across the bottom and we were consistent across the top. That's what's important in setting up a proportion. So when you solve that, 220 times 230 divided by 360, you get an answer that makes sense because it's less than the 220 horsepower that was produced by the larger engine. Now, we do have a rounding situation here, so let's go back and pay attention. Remember I said that this is going to be an issue when you answer these questions. If you just blindly type in what you see in your calculator here, I don't think Pearson's going to like it. Okay? So you notice that they told me that was incorrect, even though we all agree that that's sensible. What should I have said here instead of 140.555556?
140.
Yeah.
Go ahead, Lamont.
Should have rounded up to 141, a whole number.
Absolutely, because it says give me a whole number, and the nearest whole number, because it's 0.5, goes up. Nice. Now, they didn't say anything about proportionality here. We're just applying proportionality, partly because we just came out of a section they were talking about proportionality. We know that's kind of a thread for this whole chapter. But in a lot of situations, especially in these tech industries, proportionality is a really important tool if you're going to figure out these missing values. I'm just going to skip around here a little bit. Okay. Take that same situation and see if the proportionality works here, if it provides an answer that's sensible. 10 assemblers can complete a job in 6 hours. How long is it going to take if the assemblers cut back to 4? You can try using your proportion tool. But when you get to the end, you should be thinking about, does the answer make sense? And if there's a different way you want to think about answering it, go for it. Okay, did you try using a proportion?
Yes, but I'm not sure if I'm setting it up right.
Okay, let's take a look at how you set it up, Lamont.
Well, I put 10 over 6 and 4 over X, and then I divided 6 times 4.
Yep.
And then I multiplied it by 10. I got 2.4.
Okay. Does the answer make sense?
Yeah, it makes sense because it's lower. It's lower than 6 hours.
Okay, but let me talk you through it. You got, I mean, 10 assemblers, that's 10 workers, right?
Mm-hmm.
They get the job done in 6 hours. If I only give you 4 workers, is it going to take them longer or shorter?
You're absolutely right. It should take them longer.
Right. So this answer doesn't make sense, which means that this proportion is not actually the right tool for this situation. This is a situation where the ratio is not the same, but it's the multiplication which is the same. There's basically 60 hours of labor that need to be done. And so it's 10 times 6 equals 4 times what?
Right. Okay.
So this is a good question because it reminds you that proportions don't work for everything. And you don't want to blindly set up a proportion and solve it and call it good. You want to add your critical thinking into the process and say, okay, well, does that answer even make sense?
All right.
So what's a better answer here using this mathematical structure?
I got 15 hours. That was completely wrong, huh?
Well, does it make sense? 10 times 6 is 60 hours. And if there's 60 hours required to do something and you got 4 workers, how long is it going to take each one?
Each one, or how long is it going to take to the 4 assemblers?
Yeah, how long is it going to take each assembler? Or
I got 15 hours.
okay,
Yeah, I got 15 too. I'm not sure if I did it right.
it's good. Now, one of the nice things about doing homework online is you get that immediate feedback. If you're getting something wrong and you don't know why, what are you going to do about it?
Skill builder.
Okay, you got options, right? You got this question help, you got skill builder. I don't even know what skill builder does. Let's find out. Oh, I already answered the question right. Let's do a harder one. Oh, it doesn't even give me the skill builder option.
Or you got the question help option.
You got the question help, but you're forgetting the most important thing.
The calculator.
No, my friend. Who are you? Who is teaching you the course?
Oh, you.
Benjamin.
Yeah, man.
We done
Of
typed
course.
Hey,
Of course.
it.
and the best way to do that is to take your phone and take a picture of the screen so I have the context of the question, and then just send me a text and say, here's what I'm looking at.
Yeah.
I got it wrong. If I can see your answer, that's even better, right? If you've done some work on paper, you can send me a picture of that and say, here's what I tried. All of that is good for me to know, and I can respond to that, throughout the day. It doesn't have to be in class. Okay. I feel like we're good on this section 2, actually. But I'm going to give you, I don't know, let's say until 12:15, and I want you to just kind of get in and kind of work around, see if some questions come up, because I want to make sure that I give you some time here where I'm actually in person, so you can pop in and say, hey, I got a question. Just turn your mic on and say, all right, I'm on this. You can actually share your screen, so you don't have to do the whole texting thing. But if you want to do it privately through text, you can do that too. But take a look at 4.1 and 4.2, and then at 2:15, we'll talk about the next couple of sections. Okay, you guys got any questions? Okay, guys, I'm gonna come back together. Nobody asked me any questions, so I suppose that's a good thing. Means you were working hard and didn't feel like you needed support. It's only a good thing if you didn't stop yourself from asking questions because you thought, I don't want to let him know that I'm having trouble. I got to put that baby to bed right now. If you're having trouble, do not pretend like you're not having trouble. Let me know. That's what I'm here for. That's what you pay me the big bucks for. So,
I do have a question.
yes.
I moved forward and I went back to it. But okay, so this was actually the very first question. It had multiple parts. Um, so it was, okay, I'm trying to get it on my screen.
You have it pulled up on your screen?
Oh, yeah, I do.
You could share your screen. Do you know how to do that?
Let's see.
So if you go back to Zoom, it should be right in the center, share screen, like a little green button.
Oh, yeah.
Yeah, I was having trouble with that first one to the table one.
Here we go. Share. Can you guys see it?
Yeah.
Yeah? Okay,
Oh,
well,
because there were a lot more of those questions coming.
yeah, there were a bunch
Yeah.
in here. So I'll just exit out of this then. Oh, no. Oh,
Yeah.
Lord have mercy.
Now that's a very important point about help me solve this. When you choose help me solve this, it will send you back to the beginning so that you have to do it all over again. So go ahead and fill these out because they start off easy.
Okay, so this is. Mhm.
But can you like explain? Cause like I had no clue. Like I don't know like what I'm trying to get to.
Oh, so they wanted you to simplify?
Yeah, there's a bunch of them you gotta simplify, yeah.
Okay, so they don't say that, but the implication is that they want you to do that.
Yeah,
Okay.
yeah.
So again, the 8 to 3 comes from putting the 24 over 9 and then dividing the top and the bottom by the same number to break it down.
Oh,
Mhm.
And when you get to these types of problems, then you're kind of working backwards. I would just set up a proportion to figure out, what would the top number need to be in order for this proportion to make sense. Do you know what I mean by setting these up as proportions?
no, I want to see like another example, like how you set before when you did the fraction. Like I wasn't sure. I saw how you set it up, but I wasn't sure how you broke it down and you divided what by what.
Okay. I'm gonna interrupt your screen share. Selena, if you want to get to the question that was troubling
Yeah,
you,
sorry, okay, let me press stop. I was trying to work fast.
just get to the question that was troubling you, and then we can come back to you.
Okay, okay.
I'm just gonna answer that question more directly.
Okay.
So you wanted to see if you have a fraction like, if you have a ratio like 30 inches to 16 inches, and you want to know how to break it down.
Yeah, and like when they ask for the ratio, and it's like,
Right, and it's not just 30 to 16, or they tell you that's the wrong answer. So the point is that this fraction can be simplified. And the way we answer that is we ask ourselves, what can 30 and 16 be divided by? So in this case, 30 and 16 can both be divided by what?
well, I know off bat they can automatically both be divided by 2, but I think, do you have to choose like a higher one, or how does?
Yeah. Perfect question. No is the answer. You don't have to find the biggest number right away. You can just break it down as you go. So my first step is dividing by 2. I got 15 over 8, and then I'm looking at those two numbers and I'm saying, can I go any further or not? So in this case, you're done, right?
Like nothing goes into 15 and 8.
Right. If it was 32 over 16 and you were saying to yourself, I want to start by dividing by 2, that would just be the first step, because then you would have 16 over 8, and I can simplify 16 over 8.
4,
Right? I can keep going.
right.
4 over 2, oh, I can keep going. 2 over 1, boom, there I am, finished. So you don't have to find the biggest number right away. You can just do it in steps. Just keep repeating the process.
Right.
That makes sense?
So for that, the one Selena had, so the answer would be like 2 to 1, like for your example on the bottom, because it's like asking like.
Selena, you want to bring it back?
Yeah, 1 second, guys. And I actually think I just like figured out what I was struggling with too.
Okay, good.
Is that
Can you
it?
share it just so Dylan can look at it? All right.
Mm-hmm.
Oh my God, that's a disgusting problem.
Wait, hold on. I think I'm on to something here. Don't say nothing yet.
19 1/8 over 4 1/4. What do they hate you?
Exactly.
Yeah, you figured out my
These problems is crazy, man.
Well, that's the kind of example where you don't have to bend over backwards. If you don't get 100% on it, it's not going to kill you. But anyways, Dylan, which one were you talking about?
Like, you know how you just showed me how to like set it up and break it
Yeah.
down with the answer?
Yeah.
Like on here, you see how like the first one, like for A, for example, you saw it says 8 to 3. That just like, you like with like how you just showed us, is that like the fraction? Is it just putting it different, like 8 to 3?
Yes, that's right.
Okay, I got you.
Top number first.
Fraction that I got down, like the first number, and then the bottom was the second number. So 8 to 3.
Yep, first number on top, second number is on the bottom. So the top number goes first, bottom number comes second. Now, in terms of that, the C, D, and E, those are more proportional questions, because you would write like X over 9 equals 2 over 1, and then you would solve that.
Yeah, I want to get another example on that too, just to like make sure I got it. Because if you
Okay, yeah. I mean, I feel like I'm like super close to that one, but I need more guidance.
Yeah.
So I need you.
Okay, 19 1/8 to 4 1/4. All right, I'm gonna go ahead and share my screen again.
Should I stop sharing?
Yeah.
Okay.
19 1/8 to 4 1/4. So because these are mixed numbers and we're basically in a division situation, I would probably change them into improper fractions.
Mhm.
So 19 1/8 is 153/8. And 4 1/4 is 17/4. So this is my ratio, 153/8 over 17/4. Now, again, what are you going to simplify this to? Something to something. This problem is just mind-blowingly stupid. I would multiply actually the top and the bottom by 8, because if I multiply the top by 8 and I multiply the bottom by 8, then I'm not dealing with fractions anymore, and then I can kind of be free and move on.
I just, I mean, I divided. Well, you know, I flipped it. So I did 153 times 4, and then 8 times 17. I got 612 over 136. Is that right? Or?
Well, what I notice after I multiply by 8 is that if I divide by 17, and I just picked 17 because I know 34 divides by 17, it turns out to be 9 over 2. So that's the simplest answer. If you got there a different way, that's fine.
I mean, was I on the right track though, doing it like that?
Tell me how you did it again.
So I did 153 times 4, and then I multiplied 8 times 17 across, and I got 612 over 136, but I still had to simplify that down.
Yep, that'll work.
Okay.
That's fine. Just a longer way to go.
Yeah, I see. Yeah.
But you'll get there.
Gotcha.
Okay, don't get too hung up on that type of thing. Again, keep the 100% in mind. Like, that's one problem, and it's an example of the textbook and the writers just going crazy. Like, there's no point or purpose to that kind of mathematical work, in my opinion. So don't get lost in the sauce there. Okay, now as we talk about 4.3 and on, it moves into percentages. 4.3 is all about percent, fraction, decimal, and the kind of relationship between those things. So the first thing I would say is that it's good if you know that the meaning of percent is divided by 100. That's like literally what the word means. Per is divided and cent is 100. And so let me put the word by in there. So if I have 35%, I can interpret that as a fraction or a decimal. As a fraction, I would just write the divided by 100, but I wouldn't do it. And as a decimal, I would just actually do the division by 100. So those are the three versions of 35% that you want to feel comfortable with. So starting from a percent, if you have 62%, if you have 6.7%, if you have 3.25%, those are all things that can be turned into fractions and decimals. And that's the kind of stuff you're going to be doing in 4.3. Now, again, this problem is kind of the most difficult type of problem, but from my perspective, you know, not worth getting super hung up on, can I do that type of problem? There's ways to turn that into a decimal, especially, which is going to be the most useful form of that, which really get around the fraction complications. I think it's good for you to know just off the top of your head what a quarter is, what a half is, what 3/4 is. Maybe if you're into carpentry, you would kind of have on the top of your head what 1/8 are. You probably should have a mental idea of what 1/3 are, at least approximately, and 2/3. And I mean as decimals, right? So what's a quarter as a decimal?
125,
0.25. What's a half as a decimal?
0.5,
0.5. 3/4.
3/4, 0.75.
Right? What about an 1/8? Anybody know that? If you don't know it, you can do 1 divided by 8. That's what an 1/8 is.
0.125.
That's right. And then what is a 1/3 approximately?
0.3.
0.33, yep.
Mhm.
And 2/3, 0.66 or 0.67, depending on how you round it. Okay. Okay. So that's what 4.3 is all about, is going from one form to another. If you're turning from a fraction into a decimal, you just divide. If you're going from a decimal to a percent, move 2 places to the left, to the right. And basically, you can come up with kind of a process for each one of those conversions. But more interestingly, we want to focus on how do we actually use percentages in place. So that's what 4.4 and 4.5 are all about. So let me show you some questions out of that section. Okay, no, I want to do 4.4 first. Okay, 5.5% of 270. So what I would say about percent questions is there's really 3 types of percent questions. There's the most common, which is finding the percent of. What is 10% of 35? what is 20% of 50? These are the most common because when you're calculating percents in the real world, you typically have the percent that you're looking for and you want to know the percent of something, and that's also something that you know. So a lot of the examples that come to mind are financial examples, discounts and things like that, right? If you got a trade discount of 20%, you can take a look at the kind of shelf price and you can find the discount by doing 20% of whatever. The second type of example is finding the percent. And that means that for whatever reason, you're interested in actually calculating what the percent of something is. So this would be something like, if I have 2,300 cubic feet of dirt and I need 3,500 cubic feet, what percent do I have already? And then the third question is the most unusual question, which is finding the whole. These tend to be less common types of questions. So you know that you want to spend $300 on a part, and you know that should be 30% of the final cost of the project. So you don't know what the final cost of the project is, but you can guess the final cost based on how much the part costs. So you're finding the whole, the larger value, because you know the part. So as we're doing percent questions, they're going to end up being one of these three types. In this first type, we just multiply the percent times the value. So in this case, it's 10% times 35, or 20% times 50. And this is where the conversions come in, because you don't do 10 times 35, you do 10%, and remember, percent means divided by 100. So it's actually 10 divided by 100 times 35, or 20 divided by 100 times 50. So in this case, with the example that we started with, 5.5% of 270, that's what we have to do. We have to take 5.5%, which really means 5.5 divided by 100. And then we have to multiply by 270. Okay? So let me just see what you can do with that. You got 5.5, you want to divide it by 100, and you want to multiply by 270. This would be a perfect example of where you could immediately change this into the decimal form if you know that a half is equal to 0.5. There's no reason to mess around with the mixed numbers. We can just go straight for the decimal version of that. Okay, how'd it go? What's 5.5 as a decimal?
5.5.
Yep, so we do 5.5 divided by 100 times 270, and that comes out to be
74.25.
okay. You guys agree with that? $5.5 divided by 100 times 270.
I got 1485, I think.
Okay. So I heard 1485, and I also heard, what was the first answer? 74?
74.25.
Okay. Can I get some other people to chime in here? We got two different answers. They can't both be right.
Yeah, I got
55.
14.85.
Doing 5.5 divided by 100.
Yep. And then times 270.
Oh, times 270.
Oh, wait.
14.85.
Yeah, I got the 14.85.
So one of the things that commonly happens with percentages is because people don't actually use them on a daily basis, even though you could, because they're all over the place. You just get confused between, do I multiply, do I divide, what's happening,
Yeah.
right? And so I kind of think that's maybe what happened. I don't know where the other answer came from, but that's
I
a
don't
common
either. Yeah.
anyways, it's a good thing to be able to double check your work. And this is what practice is for, because if you get it wrong, you get the feedback, you get to try again. All right, let's take a look at another one. So what type of question is this? They got a bid, $7,860. It includes $2,100 of lumber. What percent of the bid was the lumber? Is this type 1, 2, or 3?
2.
Exactly. We're trying to find the percent, right? What percent of this bid is the lumber? We just make the ratio. So we're looking at 2,100 over 7,860. Now, when I do that ratio and turn it into a decimal, that's the decimal version that has to be turned into a percent.
Like
So
2.
I get 0.267175 bibbity bobbity boop. Is that what you got?
Yeah, 20.
Yeah, and you're already moving on to the next thing, which is change it to a percent. And how do you do that?
Decimal 2 places to the right, right?
Exactly. 0.26 is 26%. So this is going to be 26.7175 bibbity bobbity boop percent. Now, look at how it wants the answer. So what's the best answer here?
26%.
Let's try 26%.
27.
Exactly, because the next number after the 6 is a 7, so we round up. So it's not 26% is not the best answer, is 27%.
And how do we know which number to put on top of the fraction? Like,
Yeah, good question. It's not always going to be the smaller number. You can't use that as a kind of definitive rule. Most
Right.
of the time it is, because in the real world, it's
Yes,
uncommon for us to get things that are over 100%. It's not impossible, but yeah, it's basically one way to think about it is that it's a part to whole ratio. So the whole bid is the 7,860, and the
Right.
part that's lumber is the 2,100.
right.
So that's a good thing to
Okay.
keep in mind.
So put the part on the top, and then the
Exactly.
whole always goes. So the whole always goes on the bottom.
That's right.
Okay.
All right. Let's take a look at one more out of this section. So this is more of a word problem. Okay, any ideas? What type of question is this?
Number 1.
We're finding the percent of something. We know that there were this many crashes. This is the total number of crashes. We know this percent of crashes are caused by distracted driving. So when we simplify this out of the words, it's just 29.5% of 16,390. So that's what it boils down to. And that means it's a multiplication problem. So in other words, 29.5, we got to turn it into a decimal. So divided by 100 times 16,390. Okay, now let me try to find one, because we still haven't seen that third type. Told you that was the kind of the uncommon one.
Yeah.
Let me see if I could find one. Okay, this is one. Because 66% of the total yields the pure iron, which is 1,188. So in other words, now I haven't told you how to solve that type of problem yet, but I want to use what we already know. If we knew the total, we would just do 0.66 times the total, but we don't know what the total is. We do know that when you multiply it, it makes 1,188. And so how do I solve this type of problem where I'm multiplying, but I don't know by what, and I know what the answer should be? There's a couple ways we can solve it, actually. Any ideas?
Do you just divide by the 0.66?
Okay, so we take 1,188 and divide it by 0.66, then that gives us 1,800.
Mhm.
And that is the right answer, because if I take 0.66 times 1,800, it gives me the 1,188. So we basically have figured out this missing number. Now there's an algebraic connection here. We don't have to think about it algebraically, but basically, since we're multiplying by 0.66, the opposite of that is dividing by 0.66. And since we're trying to get to this unknown number, that's the way we would figure it out. Now, I think that's one of the reasons why percentages are confusing, because in one of the type of percentage problems, you end up multiplying, and in the other type of percentage problem, you end up dividing. So how do you know which one makes sense? Well, one way to do it is not worry about whether you have type 1 or type 3. You just do both. You multiply, you divide, you see which one makes more sense. Or you could use the strategy, I'm always going to multiply, but I'm going to think about whether my answer makes sense and then go the other direction if it doesn't. So everybody's got to kind of figure out what makes the most sense for them in terms of how to solve the problem, what makes sense as a strategy. Unfortunately, I can't just give you a set of steps that you will always do and it will be right. There's some thinking involved here and some reasoning about what works and what doesn't work. That's why the practice is important. Okay, let's take a look at 4.5 and think about how those problems are different than what we've already talked about. And then I'll give you guys some time to work independently and ask questions if you have it. Okay, so we started off with making something and we melted the iron and we set it in the mold. it was 16.5 inches and then it cooled to 16.25 inches. What is the shrinkage in percent? So what they mean is something that started off this long, after it cooled, ended up being a little bit shorter. And this is a common feature of physical materials, right? If you have ever experienced wood shrinking, that has to do with moisture, not so much heat, but wood does the same thing. Metals can increase in length or diameter in hot or cold weather, increase or decrease. So it's just kind of an interesting feature when you're thinking about engineering and construction. Now, there's a step that we need to do to figure out the shrinkage as a percent, which is how much did it shrink? Not as a percent, but just in terms of the units we're talking about, which is inches here.
0.25.
Right, so the change was 0.25. The basic formula you're going to use here, if you're looking at a percent change, is just the change divided by where it started. That's a basic formula that you can use to calculate percent change. They didn't use percent change as words here. They said the shrinkage as a percent, but that's the same thing. So I need to make a ratio, 0.25 over
16.50.
right, because 16.5 is where it started. So let's go ahead and divide 0.25 by 16.5 and see what we end up with.
Or 0.015.
Yep, we got a lot of repeating decimals here, 151515. Okay, so there's two things that need to happen before we put this answer in. Number one, I want to know what it is as a percent, not as a decimal. So let's change that. I want it as a percent.
It's 1.5.
Yep, just move it two places, 1.5,
Yeah.
151515. And then I got to look at the instructions about the rounding. If the decimal does not terminate, round it to one place.
So then 1.5.
So we get rid of all of this, and the 1 tells me to round down. So we're going to go with 1.5%. Okay. Boom. So a few more steps there. The percentage part is the same. We need to make a ratio. We're going to divide. But how we do the percentage is a little different because we're finding the change, and then we're going from there. Let's look at another one. A lot of words. We got a table. All right, what's happening here? Okay, this is about HVAC. The more area you have, the more capacity you have to have in your HVAC unit. So you can't just stick any old HVAC unit when you're building a new home or you're trying to fit out an air conditioner or something or a heater. You got to make sure you're taking into account the capacity and the size. Now it does say if the room is particularly sunny, add 10%. And if the room gets very little sun, subtract 10%. So first of all, for the first question, 260 square feet, what would the normal capacity be based on the table?
6,000.
Yeah.
Or, yeah.
6,000 BTUs per hour. BTU is a British thermal unit. It's a measure of energy. So basically, we need 6,000 BTUs per hour in a normal room, but there's a trick here, and this is why you got to read carefully. It's a sunny room, right?
Yeah.
And so what do the words say that we have to do to the capacity?
You have to add 10%.
Gotta add 600.
Add 10%. And Ricky's already done the math. 10% of 6,000 is 600. So we need to add that on. We got ourselves our answer. Okay. It's not too bad, right?
Mhm.
All right. Let's try another one. %5 loss of power, and the output is 342 horsepower. What is the input? So we've got a 5% loss, and then we end up with an output of 342 horsepower. So how much did we start with? So there's a couple ways to do this problem. I want to present an idea that we're going to use later when we solve more word problems. Do we know what the input is?
No,
Do we know how much power was lost?
5%.
True, but do you know how many
Oh.
horsepower was lost?
No.
No, you don't, right? You know it was 5%, but you don't know how much it was. You don't know if it's 10 horsepower, 8 horsepower, 3
Yeah.
horsepower. So we don't know either of these things. That's not helpful. You do know that we ended up with 342 as our answer, okay? So let's just start with a guess. Just give me your best guess. How much did we start with as an input? Then we lost some power and we ended up at 342.
Let's see. My guess, I'm just gonna say like 352.
Okay, great. Don't spend all day thinking about the best answer. You're not going to guess the right answer right off the bat. It's unlikely. Why is 352 a good guess? Anybody want to back Selena up on that? I think it's a good guess. Why?
Because it lost 5% of its power,
Yep.
and that's pretty close
That's
in
right.
the
So
range.
we know it's a little bit more, but it's not a lot more. It's not like I had 2,000 horsepower. I just lost a little bit of power, right? So I'm not going a lot bigger. I'm just trying a little bit bigger. So now we can try to see if this is the right answer. What's 5% of 352?
Mm,
Go ahead and do the math. Don't say it out loud. Give everybody a chance. We want to figure out the loss, because if we figure out the loss, then we'll know whether this is the right answer or not. So what's 5% of 352? All right, what'd you get?
17.6.
You guys agree with that?
Oh no, I got 17.6.
You guys agree with that?
yeah, something like that.
17.6? I don't hear a lot of confidence out there.
I'm pretty sure.
Just 5 divided by 100, right?
And then
Times
you multiply.
352.
Yeah, like 17.6.
Good, 17.6. So if my loss was 17.6, then how much would I have ended up with if my input was 352?
$334.4.
So did we guess the right answer the first time?
No, but we're close.
No, but it's not bad, not a bad guess. Do we need to go up or down?
I don't know how I originally came up with 5% loss here in my combination.
What do you mean, Ricky?
I don't know why I took 17.6 divided by 3.52 and it gave me 0.05. I had my mind somewhere else. It came up with the 5% loss, like I was doing.
I
the
think you went in
equation.
a circle. If you did this calculation and got this number, then if you do 17.6 divided by 352, that's going to take you back to 5% because that's what it
Yeah.
is.
Yep, that's exactly.
But we're trying to see whether it was the right answer. After we lost this amount, did we end up with the output we were looking for? The answer is no, so we need to get bigger here. Let's try 360.
Makes sense.
Is it 18?
So the loss would be 18, and is that good?
Yep, it's good.
Because that would take us to the right answer.
Yeah.
Now, that's a roundabout way of solving the problem. That's a way of solving the problem that doesn't require anything new. So I wanted to start with that because I want you to know, first of all, there's lots of ways to solve problems. There's not just one way to do it. This is a trial and error approach, right? And this is going to be very valuable for people, especially if you kind of are very anxious about algebra, you don't have a lot of algebra skills. You can solve complicated problems by using trial and error and being logical about it. You don't have to be able to write equations. Now, the way that you would technically do this problem is you would turn this around and say, if we have 5% loss of power, then we're talking about 95% of the input is equal to the output. And then from there, we have an equation that we can solve or a problem that we can solve. We don't know what the input is, but we know the output is 342. So if you take 342 and you divide it by 0.95, then boom, you get your answer.
Wow, that seemed like a simpler way, right?
It's absolutely simpler, but how can you look at that problem and be confident that you know, okay, where did the 95% come from? Why are we doing this whole divided by 95%?
Yeah.
So that's the part that would take more practice.
Yeah.
But you're absolutely right. It's way simpler to be able to do something like that.
Yeah.
How did I know to do 95%? Well, it's because I started with 100% and I lost 5%. So that's where that number came from.
Right.
Okay. So my loss of 5% turned into 95%.
Gotcha.
And then this relationship, again, I'm trying to frame it in the percent of equals to kind of think about how I would write this out based on the information I have. And once I see the missing value here, then I know I need to turn this around and divide to answer the question. Okay, let's try one more here. And then I'm just going to give you guys some time to work on some stuff. Again, lots of ways to do this problem. So don't feel like there's pressure. You got to remember the right way to do it. You're trying to apply your understanding about percentages and how you can attack every specific problem that you get.
It's like I don't even know where to start, honestly.
Yeah. Got a bunch of numbers flying around. The output increases by 30%. Do you know what the output was?
I'm not sure.
I mean, they're kind of throwing different words around that, you know, again, not knowing the context, if you're not in the sort of small engine trade or haven't done a lot of work, you might not easily connect up the word power output with one of these numbers. But if you know that this HP stands for what?
Horsepower.
Well, there's the hint, right?
Right.
Because we're talking about power here. So the 80 is increased by 30%.
Oh, okay.
Give you some time to work on that. If you guys are feeling good about it, you're welcome to work on some of your own problems. Anything from section 4. If one of the areas seems like it's going to be more problematic for you, you're welcome to dig into that. Ask me questions if you get stuck. Unless people ask me questions, I'm not going to talk anymore today. You're welcome to sign out whenever. But keep in mind that your goal is that by the time we meet on Monday, you're going to be done with the arithmetic review, the quiz, all this chapter 4 material, and the chapter 4 quiz. That should be your goal for coming to class on Monday. If you don't have it ready, it's not the end of the world, but it's not a good sign in terms of your organization and prioritization of your life. The reason the students fail this class is because they don't find the time to put the work in. That's it. Nothing here is bigger than you in terms of your brain power and what you can do mathematically. I know it. But you got to find the time to do it.
I think it's like 104 horsepower. I don't know if I did it right, but.
Right.
So I was kind of confused on what number to go next. Oh, yeah.
That's it, man. So, you know, let those successes build you up. If you're having trouble with something, take a picture, send a screenshot. I hope you have my phone number already in your phone. You know,
Yeah.
you're welcome to text me anytime you're working on stuff and you're struggling with it. Sometimes the mistakes are small. They're rounding errors. Sometimes they're bigger conceptual mistakes, but I can give you the feedback and the guidance to get you unstuck.
Right.
Key is not to get on one question and kind of get yourself into a hole where you're like, I can't do this, I can't do this. I'm frustrated, I quit. So just make sure you have your resources kind of set up and available for you.
Right. And are you gonna like upload the video of like how to do because the thing that'll get me is I'll like, since like each section is like a different thing you teach us for each one, so I'll like forget. Like
Yeah,
I'll be.
so what I'm gonna do after I end this meeting is I'll upload this video, kind of do some editing and upload this and make sure it's in the announcements. So you should see in the announcements, the math stuff we did on Monday was just talking about fractions. I processed it, uploaded it. You can review it if you need it. Same thing will be for here. Anything that we talked about, you'll be able to go back and watch it again.
Okay. Yeah.
Okay, Dylan?
I'll be on like 4 or 5 and be mixing it up with stuff we learned at 4-1. That's why I need the video so I can like go back.
Gotcha. Yep. And a big part of that is going to be what you write down. So make sure that as you're doing your work, you're actually writing stuff on paper, giving yourself little breadcrumb trails so you can come back and look at things and say, okay, this is how I did that problem before. That's going to be useful to you.
All right, Ben.
You can head out. You can stick around and do work if you want. I'm going to stick around until 1:45, another half an hour.
Yeah, I'm going to try to go through some of these questions and I'll text you if I have any
Sounds
questions.
good.
All right, see you, Ben.
All right, Benji, I'm probably gonna head out. I'm get started here on these questions in a little bit.
All right, Ricky. You be good.
All right, have a good one, Benji. I'll text you if anything.
All right, sounds good.
All right, Benjamin, I'm gonna head out also. I'm also gonna go through the lessons.
Okay, Lamont, sounds good. Text me if you got troubles.
Same
All right.
here.
All right.
See you later, Ben.
Bye, Selena.